Welcome to this video in the series Seeing Sound. In this episode we will try to understand how sounds mix together and what that sounds like. Since I don't know the order in which you've been watching the videos, I will re-explain what you see on the screen here. This is an oscilloscope and is displaying two different signals. This one in the yellow is actually the signal you're listening to. This signal is also being sent to this frequency spectrum tool, and it's displaying low frequencies to high frequencies. The higher the peak, the louder that particular frequency is. This one is a same tool, except now it displays louder signals as white, and it scrolls the screen up so you can see patterns. So if I say different words, I get a different pattern on the screen. If I go woo, you can see how the frequency goes up and then comes back down again. So that's basically the setup. So first of all, in another video I was looking at simple sounds, a sawtooth, sine wave, square wave, and what they looked like and sounded like. Now on their own they are fairly simple sounds, and it starts getting more interesting when you start to combine them. Now as a prelude to combining sounds, what I want to show here is a very simple demonstration of how the phase or the polarity of a signal changes with the sound with time. So on the system here, I have a simple triangular wave, and you can see the blue and the yellow, where there's a peak in one, there's a peak in the other. And what I can do with this control, I have the output from the oscillator going into this device here, which is a volume control, but it can also invert the signals and also have the sound coming in here. So the same signal is going to two places. This control can vary the ups and down value, polarity, sorry, and then it's being remixed back onto this volume knob down here. So what I'll do is I'll show you, so the bottom screen is what you hear, and the top screen is the output from this control here. So what I'll do is I'll just make them the same. As you can see at this moment, the peaks and valleys align with each other. So if I can do with the top one, I can go back to 0, and now I can go upside down. So you can see at this point, the peaks and valleys are now out of sync. Whereas a peak is a valley, there's a valley, there's a peak. And if I add these two together by turning up the mixer, I think should be louder, it gets quieter. Because what's happening is that the valleys and peaks, when added together, become 0 basically. So at this point they cancel each other out completely. And notice obviously it's quiet. So if I turn down the upside down signal, we get back to the original. And if I keep going the other way, so the in phase gets even louder. There you go, so. switched it to the blue is the top of this, shows the output from the mixer. Yellow is what you hear. So again, I'll put that sound up. And I can take another sound, the same shape from this other oscillator, and add that. Now these two oscillators are not necessarily always exactly the same frequency. And what you're seeing here is that they have the two waveforms are slightly out of synchronization. I'll just move that beyond the mixer's range, and there's no signal available at all. Likewise, we can go the other way and end up with basically almost no signal. So this is just using a static voltage, not even a it makes no sound whatsoever. Yeah, listen. No, I can't listen because if I just this is the signal. It sounds like has no sound. So even though it has no sound, it affects it does affect the actual timbre of the sound. So for instance, I can even actually drive the same thing from say the plus the other tone, and obviously that's way below what you can actually hear. We can actually get about somewhere around there is when you hear a sort of click, 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 click type sound, and you can see the sine wave in the output. So again, we can turn the oscillator back up again. So it gives some interesting effects. Problem with the saw is that very fast edge on the waveform makes it click, which may make now we're just adding two note signals together, and we're keeping it well below the clipping level, so it's not flattening at the top. We could add a bit more. Yeah, So that goes through some of the different sounds and what you hear when you do various types of mixing of signals together. We heard the way that if you mix the inverse signal, it actually gets quieter as you turn up the volume control. We heard that when you have two signals, two different oscillators which are not quite in tune, as they drift apart, they become in phase, and it's loud, and they go to the point where there's opposite phase, and they cancel each other out. Different combinations of wave shapes give different sets of harmonics which sound different. We've also seen that even putting a soundless value in, which is a fixed value, can make the timbre change because we can drive the mixer stage into clipping mode. And the clipping, because it flattens out, it tends to add the third harmonics. Clipping a square wave has no real effect in the sound, but clipping obviously a sine or a triangular or a sawtooth makes a big difference. Likewise, if I made my voice clip, you can hear it'll go pop, make a rather bit of a rasping sound. So if I drive up the volume here, it can go into clipping mode and it really starts to sound bad. So there we have mixing.